Hello, can you hear me? Hello, can you hear me? Hello, what's up? Can you hear me? What's up? Hello, good afternoon, good evening. Can you guys? Am I audible? Can you hear me? Okay, great. If you can hear me, I guess we can continue with today's task. Yeah, all right. So yesterday we actually covered 4 modules. Um, all of them were focusing on hardware. So today we are switching things up a little bit. We'll be dealing with the software side of this training. Yeah, so if you to remember what happened yesterday, mm, let's just say all of the code or everything that we did yesterday was done on the device. Okay. The web pages that were served, the controlling of the vehicle, everything was being served from the car itself, the robot car itself. So you might ask yourself, okay, what if you want to build a platform around this robot? Or what if you want to control multiple vehicles, such as a multiple robot car? How are you going to do that? So today's task is going to answer this question because we are going to develop a software that's going to interact with our hardware device. So, mhm, without wasting much time, let's get to work. So I'm just going to give you like an overview of what we'll be doing just to differentiate what we did yesterday from what we're going to do today. What so yesterday, yeah, like I said, everything was being run on the robot car or on the hardware device. So this is basically what we were dealing with yesterday. We had the Arduino Uno, which was as a slave based system, and then with the ESP32 came, and then we had the web browser. Well, the web browser is the client, so it was fetching uh, the web page from the ESP32. So basically, the ESP32 itself was serving the web pages. So the thing is, there is only so much we can do on the hardware device itself. If you want more flexibility, you're going to have to find a way to develop a platform outside of this um, hardware device, but making sure that we maintain real-time communication. So what we'll be doing today is something that is a little bit different. So we are going to have, okay, let's just say the hardware part is not going to change that much. We are going to have a server. Yeah. We have a server here. So we're going to build a Node.js server, which is the back end of our system running on port 300 and 3001. Okay, so this server will be interacting with our ESP32 microcontroller via HTTP. Okay, so basically we'll be polling from this API endpoint every 500 milliseconds. I mean, this is not the best, but for now, this will do. And then we will be forwarding our commands via a post request to this API endpoint that is available on the device. And then we're going to have web dashboard built into it. So it will be communicating with the server, like this backend via WebSocket. Basically, this backend will broadcast messages from the microcontroller via WebSocket, and the microcontroller will also publish the camera feed to the dashboard, and then we'll also get live distance via this socket. And then we can send motor control targets um, via the web socket. So we also have status alerts to show whether we are connected or not. Also, what we can do, we can go straight to the code without wasting much time, because that's where the fun part is going to. All right. So let's just start by looking at this the README file of this task, so that we understand what we're doing here. I'm assuming that all of you know the repo. We've sent that repo to the Discord server, so you should have access to the code. So this is basically the new architecture that we'll be dealing with today, the one that we just discussed. So let's say the REST API runs port 80, and then this is the video streaming running on port 81. So this is the folder structure, um, this module that we're talking about today. So we'll go into detail, but for now, this is just an overview. So we have the hardware part. So the hardware part is basically what we were dealing with yesterday. So we have the Arduino in the ESP32. So this one actually it didn't change. Just use the same module from yesterday. This and, we just made some adjustments here so that we communicate with the backend server that we developed. All right, so new content. Let's just say the dashboard part of this module is this backend and the front end. So we have a simple server. I'm going to show you how it works. And then we have the environment variables, the configuration file, and the readme that showing the steps of on how to run this. And then the front end will have the package JSON file with the dependencies, and then the vit configuration file, that's the configuration file, and the index. But since it's React, this is the entry point of our the HTML page of our React code, and then the top level readme for this front end module. And then we have the source main file, the app file with main layout, the app.css with the styles, then then we have the hooks. We only have one custom hook that we'll be dealing with. And then we have multiple components that will be showing on our page. So basically, the prerequisites for this module are as follows. You need to have nodes installed. So at least version 18. Yeah. And then, I mean, when you install node, it comes with NPM usually, you know, of which you need the node and the package manager. Then you need VS Code. VS Code is this text editor that you can pick right now if you want that to be using. And then you will need Arduino IDE. You learned how to set this one up yesterday, so we won't be going through it. Okay. Of course, we need a browser. We recommend Chrome, but you can use any other browser that is supported. Okay. Okay. So the Node.js installation is easy actually. So you just go to this node.js.org. Okay. So if you are depending on your operating system, it gives multiple options. So we just go to get node, and then if you want, you can let's say you're on Windows, right? You can download this MSR file and then you just follow the steps to install it. You can also use if you're on Windows, you can use the PowerShell. You can just run this command. Start with this one, then you use choke to install. Then after that, if the installation is successful, you should be able to see the version of Node after running this command, or the version of npm after running this command. So it's straightforward. And then yeah, we just have this command. If you're on Linux, you just follow the steps. And then VS Code installation, straightforward as well. Just go to this link, and then you go to download. Depending on your system, if you're on Windows, you can choose either the user installer or the system installer. If you're on Linux, you can download this Debian file. On Mac, they have this DMG. You can choose either for the Intel chip or the Silicon, depending on what you have. So this part is not difficult. If you have any, if you face any challenges, feel free to ask in the Discord server. All right, so basically this is just an overview of how to run this. So this part 1 and 2 we did yesterday, so we won't be dealing with this. Okay. How to load the program to Arduino or to ESP32. We're assuming that you already know how to do this, but anyways, with time, all of you will be able to figure this one out. All right. So this part is new to you, part 3 and part 4. Okay. So this is like the setup for you to be able to run the backend and front end. So starting with the backend, you just uh, change the directory into the backend folder, and then um, we have an example configuration file. This file just contains this ESP32 IP address and port where we'll be running the server. So this command is just going to create a new env file because it's not going to be committed. If you can check the git ignore, this file is not going to be committed. So this command is just going to create this file, and then you can update the, the IP of the ESP32. Okay. And then run npm install to install all the modules. For those that are familiar with the React or Node application, this should sound familiar because these are the regular so the regular commands that you run. And then npm run dev just run the server on your local machine. So to start the front end, it's almost the same. You cd into the front end folder, which is this one, and then same command to create the env file, and then install the dependencies, and then run the dev server. So just to give you an overview of the endpoint that we have on the microcontroller, we have this API telemetry get. It's a get which means it accepts get request. So it will send the distance. I'm sure you're familiar with this. This is the distance um, between the sensor and the nearest object, and then with the motor state, whether it's moving forward or backwards or left or right, and then whether it's connected or not, and half time, and then with the status to get the status of this, and then the commands depending on this is to send okay, this for those commands, this is F forward, backwards, left, right, and stop. So yeah, if you want to send a command, post this CMD with the value. So it could be either F or B or A or F. Okay. So basically, yeah, we have this access control allow origin for calls, uh, cross origin resource sharing, because two we have the API running on let's just say they run on multiple or on different origins. Okay, so we need to allow calls. So the dashboard features it is camera feed, live distance chart, motor control panel, then the status bar. So I'm going to show you all of these when we go into detail. Then we have the WebSocket protocol. Okay, so this is the communication between the server and the client. Okay. So that's the structure of the object. So then we have the client and the server. This just to send a command, and then we have and what okay, yeah, this is to broadcast. All right, so yeah, this is just the overview of what we. So let's go into the code itself, explaining what is going on, and then we can run it. So let's start with the backend. So the structure of the backend with the node modules here, which contains all the dependencies, and then the env file that we were talking about earlier. So this is the IP address of the microcontroller, that the device, the hardware device. So when you load the program, it's going to show the IP address. So make sure you update this, otherwise it's not going to work. Okay. The port. This is the port where we are running the backend. All right. So this is an example. This one will be pushed to the repo, but this one will be ignored. So when you run that copy command, it's going to create this one. This is the one that's going to be used by the backend. Okay. So of course, we have the git ignore. It's ignoring the env and the node modules and the build, just in case we build it. Then the package, the JSON, it contains the dependencies, and then the start commands and everything. All right. So, we only have four dependencies. Four was for cross origin, which is cross sharing. .env for loading the ENV file, then Express, of course, because this is an Express application. So Express is our framework. Then this is the WebSocket package. All right, so let's see our server itself. It's a very simple server that's handling kind of complex stuff, but it's works. We hope you enhance it. Okay. Let's start from. So here we're just importing the Express, of course, and then we import calls, import PTP, then import web server from WebSocket, and then we import .env and immediately essentially. All right. So this is the ESP32 IP that we set in the here. We are loading this value from the env file, which is this. Okay. If we don't have the value, we set a default like this. And then the port, we're also loading it from that env file. We just pass it to an integer because it will be a string. If we don't provide one, we have a default here. So this is the polling interval. So like we mentioned earlier, backend is going to pull data from the ESP32 or from the hardware device at this interval. So you can change this, you can experiment with this just to see what's going to happen. But for now, we think this is the more efficient option. So you can experiment if you want, but this is what we're using. And then we have the timeout here. And then we have the state. So this is the structure of the data that's going to come from our hardware device. Okay. We are going to have the distance. I'm sure you're familiar with this. This is the distance between the sensor and the closest object. And then the motor state, by default, it will be stopped. So that's why we assign S. And then connected, the default value is off because by default it won't be connected. But once we are connected, the state is going to be changed to true. Then the uptime in millisecond by default is 0. Timestamp is just the current date. Okay, ESP32 online, that's a variable that we declared false by default. So here we instantiate our express and then use this middleware. Cause is for cross origin resource sharing, and then express JSON to handle JSON data. All right, so we do have some endpoints just to check. So this one is to check the health, whether our server is running properly or not, and then we have this telemetry. This one is just going to give us the latest telemetry because it caches the latest. We just use this to check to see if we are actually receiving something from the hardware device. And then we have the status to check the status of the ESP. So we can test this. We're going to test this just to see so that we can see the structure of the data that they return. So this one is a post command. Okay, it's a post request. I would say we're sending a post request to this endpoint. Okay, so when you are explaining, like when you're showing how this thing works, it's going to make sense to you, okay? So don't worry if you don't understand it yet. But when we just think of using this post ESP32, we are posting a command, whether it's forward or left or right, depending on the command, we are posting it to the device. So when everything runs, you get the bigger picture. Okay. And here now we are initializing we are creating the server. Okay. Using our WebSocket. And then the WebSocket connection. Okay. So we have on message and on close. So on message, if it's a command, then we post this command to ESP32. Okay. So at the same time, we broadcast to let's just say we broadcast this to all the connected. All right, and then of course we have the on close. If the connection is closed, and then we just log that okay, the client has been disconnected. So if we have multiple clients, we are going to see the number of connected clients to a thing. All right, so this is the broadcast function that's going to broadcast to all connected clients. Okay, so just stringify the JSON object. Okay, so we loop through all the clients. Okay, so if the client is ready, we send the payload. So this is a function to fetch from ESP32. It takes in the path, and then yeah, URL. Remember that ESP32 IP address that we set in the ENP file. Okay, and then the path. So if you remember, um, if you are familiar with HTTP, you know starts with the HTTP protocol, and then the IP address, which is the host name, and then the path it could be slash API slash command slash API slash health or slash API slash something else. Okay. So this is just formatting. We're formatting our URL. So we have the timeout that we declared. Like we had content that is okay. So we'll get this get response on data or on end. But anyways, we'll see everything. Okay. Okay, so this is the post to ESP32 function. I believe we use it here. Okay. This is something we use to post um, let's just say the command to this API command endpoint. Okay, so it takes in the command. Okay. So basically we have that part and the data which is that command that will be posting. So we are prepared since it's asynchronous, we're preparing a promise. So we have the payload will just stringify this data that we receive here. And then of course the host name is the IP address. The port is 80. If you remember, we said it will be running on port 80. We can see it here. Okay, this is the port 80. Okay, then the path is the command API command, and then Mm, the method is post, of course, because we are posting data to the device. So I hope you understand HTTP or you are familiar with HTTP method. We've get, post, we've delete, we've put, um, we've options. Yeah. So, but the ones that we mostly use get, post, delete, and put.
All right, so we have that timeout that we set earlier. So after that time, I mean the request is it will be considered timed out. Okay. Then the headers, we set the content type to JSON. Okay, and then the content length will be the length of the payload. And now we you send the request. Okay. So on data and then on error. Well, so this just prepare we are preparing our request and then we send it. Okay. After sending it, we end. All right. So this is the function to pull the telemetry data. Remember, we said we're going to pull data at the interval of 500 milliseconds. So we're going to see how this works. Okay, so we're just fetching data from this endpoint every 500 milliseconds so that we can update the data. It's going to look like we're updating in real time, but we are just fetching data at a regular interval. Mhm. Okay. So now we listen to, okay, this server, this backend, it listens on this port. We set this port. Remember that 3001. This is the port we set in the environment variable. So this code that we have here is everything that we need for our backend. This part is the one we just described. Okay. This file contains this. Okay. This code. Okay. So for now, let's just run only the backend. We're not going to see any, buttons or any UI. Let's just run the backend to see what we just test those endpoints that we currently have. Okay. I hope we are still together. Okay. So if you guys have any questions, please feel free to ask, okay? Because we don't want to leave some of you behind. All right. So let's let's run this backend of ours. So let me just clear everything. All right. Mm, so please make sure you are in this backend folder, okay, for you to run it. Okay. But what I can do is let me just clear everything so that we can navigate to that code. Okay. We can go 3D. Okay. This should be training and then okay. No, it's not backend. It should be P5, then backend. Oh, so this is where our code is. So if we do ls, we're going to see the file that we have in the this backend folder. We have node modules, we have the package.json, this one, we have package log, readme, server. Okay, so let's run it. Okay, run dev. Okay, so mm, just so you know, we have already loaded code. The code, like let's just say the device is code. So we're already connected to the device. It's running on this port. I mean on this IP address rather. So all right. So let's check those commands that we were talking about. All right. So we said we have the health. Okay. We said our backend is running on localhost at port 3001. Okay. So what we can do, we can just copy this API help. All right. So okay, we can just test it and then we'll do API / help. All right. Mm, Sorry, help, not help. All right. So the health endpoint is just going to return this. Okay. Is the ESP32 online? Yes. How many clients are connected? We have 0 so far. So when we run the front end, this is going to show the connected clients. So let's check another command. So as you can see, it returns this JSON object. So okay, true, whether we are online or not, and the number of clients. Mhm. All right. So let's test this endpoint, this telemetry. Mm, okay. What the hell is going telemetry? Okay. So telemetry is going to return the cached telemetry data. So like I said, we have the distance, the motor state. So right now it's S because it's stopped, it's not moving. Is it connected? Yes, it's connected. Uptime, so it's been up for this long. And then timestamp, this just the current timestamp. So if we refresh, this is going to keep changing. Okay, you see the timestamp it changing. So this is just the latest cached object. So if we refresh, it's still going to be changed. And so you can click this. Mm. All right. So this is the endpoint to get the status. So you can just go to API status. Okay. Okay. So this is the SSID. This is the Wi-Fi that our ESP32 is connected. And then its IP address. Okay. And the free IP and the uptime in millisecond. So we're just using this endpoint to test if our server is running or not. Okay. And then just to check the health and the status. But so far we cannot actually see the UI because this is just the back end. So, so what we are going to do next is to talk about the dashboard, this dashboard, the front end, okay, and then this WebSocket communication. So we're going to do it step by step. But before we do that, let's take a short break so that you guys can check the code because you do have access to the GitHub repo. You can just clone it and then try to, understand the code because it's just a simple service in one file. If you are familiar with Express, I'm sure you'll be able to get what's going on. Okay. So after 10 minutes, we are going to talk about the front end. Okay. And then we do a demo. We explain step by step how this connection, like I said, this communication between these three um, nodes, also these three modules. We have the front end, this back end, and then the microcontroller, or let's just say the hardware device. Okay, so let's take a short break. Okay. Yeah, we'll be back in maybe 10 minutes.
Okay. I think we should resume. Okay. So let's talk about our front end. All right. So, like we mentioned earlier, yesterday, mm, the web pages that you saw were served from the microcontroller. Okay. So if we check P4, okay, if you check P4, what we did yesterday, with ESP32, you are going to see this interface. This is the HTML code that was served. But today we are doing it differently. Instead of saving the, the web pages on the device, we create a dashboard. Okay, just create a platform that's going to communicate with the device, getting data, sending control commands. Mhm. All right, so we are done with this server side. So now we are going to talk about the dashboard or the front end of the system. All right, so this was the back end. Now we're going to see front end. So this one is going to be, it has more files, but don't freak out. Okay, it's simple. All right, so let's just say all of our code are going to be in the source file. Okay, that's where everything is going to be. That's where all the magic happens. So I'm going to assume that some of you are familiar with React. Yeah, if you know React, then this should be a piece of cake. It's just a very very simple page. All right, but even if you are not familiar with it, this should be somewhat easy to grasp. Okay, so we have the main entry of our app that's going to uh, serve this app, which is our layout. So this is where we do most of the processing, and then define all our components. So, let me just give an overview, like a very brief overview. It makes sense when we actually run it, but let me just give you an overview of what's going on here. I will run it. So the page itself, of course, that has this header, and then a status bar. A status bar is just a component that takes these three procs connected. This is the connection status. Okay. Is the ESP32 connected? Yes or no? So this is connection to the backend. Okay. This is the connection to the ESP32, the microcontroller or our hardware device. Then this distance is the distance part of our telemetry data. Remember that object that we receive when we get our telemetry data. Okay. We're just getting this distance part of it. Okay. We pass it as a prop to this status. And then we have the main section of our page. we're going to have the camera feed from the device's camera. Okay, this is the feed, another component. And then, of course, the left column is the camera feed. The right column is the control panel. This is where we have those joystick control buttons to control left, right, or forward, backwards, top. Okay. And then at the bottom, this we have this real-time chart that it occupies the width, and then we have the footer. All right. So from here, let's just do it step by step. Okay. So that you understand what is going on. Yeah. So of course, this is when initializing a WebSocket, and then that setting state is sending, it's sending. Then we have this end of command. It's a use copy. This just the function that we use to send commands. Okay. So like I said, we have forward, backward, left, right, and stop. So we just have this command that we send. We wait it out. Okay. So for everything to make sense, let's do it with a bit of visualization. Okay. All right. So we need to make sure that our backend is running. Okay. And then we can open a new terminal. Okay. So we cd into training, and then P should be P5. Okay. And from so we do ls, we're going to see the files that we have our front end. This ls. Okay, these are all the files that we have. Okay. In our front end, I will see the more index, not modules, source. Actually most of the code is in this. All of it is in the source directory anyway. Alright, so we run the front end. If you remember, we have that command here. Let me put upward. Alright, to run the front end, of course, we need to install dependencies. I have installed them, but just for you to see, you can just do npm install. It's going to install all the packages, and then to run it, just npm run the run. Alright, so it's going to tell us that okay, our app is running locally on this port, so we can just we can just copy it or just control and then click it. It's going to open this web page. All right. So from our code area, we say we have the header, okay, which is let me take this. All right, let's go to the app. The header, the heading one is this one. And then with the status bar, okay. it takes in these three props. You see how they're going to be used. You see, backend, whether we're connected or not. So this one, okay, is this value. Are we connected to the backend? If you are connected, it will be true. Otherwise, it's false. Are we connected to the ESP32? If you're connected, it's true. Otherwise, then the distance. So we're just using this one to control this label here. So depending on the proximity of the sensor to the closest obstacle, I'll say. If it's closer, it's going to change. Like, okay, let me put my hand here. It's going to change to a danger. Oh, so that's why we have the, all right. So if you put your hand there, actually, this graph here is going to show our telemetry data in real time. Okay. So, like I said, we have the camera feed here, the motor control here. Okay. So this is Mr. Wen. Okay. All right. Okay. You see, this it changes depending on how far the closest obstacle is. All right. Uh, okay. I think this should make sense, guys. Okay. All right. This is the main part. Okay. We have the camera feeds on the left column. Then the right column will have the motor control command. All right. I want to try to move it, but hopefully it's not going to go wide. Okay. So turn right. Okay. And then turn left. Okay. Oh, so yeah, this status here, it also this step it also changes. Oh, okay, let Mr. Wen wants to record this video so that he can show you guys. Uh, alright. So we have the stream, we have the command. Okay, go back. All right. Go forward. We can go left. We can go right. But basically, guys, this is almost the same task that we did yesterday, but it's a little bit enhanced because we are now having multiple modules or multiple components communicating. Okay. Yeah, we are separating content instead of using the device to serve web pages. We can develop a platform around it. So we can say this is the end goal, let's say, because want you to be able to build a platform. Okay. What else can you do with this? Okay. You have the data. You can store it in the database. Okay, you can control multiple devices. Once you have this kind of platform, it opens many doors. Okay? You have many use cases that you can implement. That's the very basic. Okay, this is the very basic implementation of this um, architecture that we're dealing with today. So once you understand how this works, you should be able to enhance. But let's just dig a little bit deeper so that you kind of get the the workflow. Like when we click this button, what happens? Then we have this stream, we have this real-time telemetry data feed. Uh, I hope you can still hear me. Yes. All right. All right. So let's start with our status bar. We can just see that we have a component here, status bar bit, but we don't really know where it is or what it does. Okay. So if we go to our components, you can see all the components that we have. Status bar is here. The camera feed is here, and then the control panel. The control panel is here. Then we have our telemetry chart. From here, you can actually see what we have from our page here to be able to get the idea. Okay. All right, let's take a look at this status bar first. Okay. So status bar, it's a very basic component really. So we have these classes that we use to basically, okay, let's start with the props. Since it is TypeScript, we do need to create an interface for our props. So we have connected, ESP32 connected, and distance. Those are the props that we pass from, if we check here, we pass these three props, we just define them here. So we have the alert class, if distance is less or equal to 10, return alert rate. So we just use this to control, just to set the classes for our styles. So if it's alert red, this color it will be changed to red. Okay. That's we just conditionally setting the style. Okay. Alert red, alert orange, alert yellow, alert green, depending on this D, which is a number. This is just the distance. Okay. Then this is the alert level. But remember, we have the color and the label. So the color corresponds to this level. So also, since we are using these values, so this one corresponds, alert red corresponds to danger. Then with this one, close, this one, caution, and then this one, clear. So if we check right now, it's clear, yeah, and it's green. If you check here, the alert green and clear. So now this is our component. Yeah. It's basic. Okay, so it just shows, okay, backend, is it connected or not? Okay, so here we're just conditionally setting the class depending on the
Distance. Okay.
so actually this is these are the only
Items that we're displaying. So it's a very, very simple component. Okay. It just says this backend connected or not, ESP32 connected or not, then the distance. So we show the alert label and also conditionally set the class for styling. Okay. And then next we have the camera feed. Okay. The camera feed is this one, this part. Okay. This is the camera feed from the device's camera. So if you take a closer look, you notice that your device has a camera. So this video here, this feed is coming directly from the device's camera. So that's why when we move it, you can actually see that, we are moving. All right. So if we go backwards, okay, you'll see video. Okay. So this is the video feed. So let's see the component. So we're just rendering the component here. We pass it the stream URL. So the stream URL is this one. So the tricky part here is that the stream is coming directly from the device. Okay. It's coming directly from the hardware device. So we just set the URL here. We pass it as a prop to our camera feed. Okay. Let's check our camera feed component. It's a very simple one. Okay. You just an image tag with the source being that URL, and then on air. So if it's not connected, it's going to show like a message like, okay, the camera is offline, check the connection. On error, it's just going to show this one. But since we don't have any errors, we are connected, we can actually see um, the camera feed. So this is easy. This is a very basic component. Okay. Mm, all right. So what have we covered? We have covered the status bar, okay, and the camera feed. So let's look at the control panel. Well, this one is kind of doing some gymnastics. Okay, so let's pay attention to it. So this component, it takes in three props on command. Okay, so we pass in this handle command. It's a function actually, and then it's an asynchronous function to be specific. And then the current command that we are passing. Okay, so it can be telemetry dot motor state, which is the state where we're passing, or it's stopped or stop by default. Okay. So disabled whether we are sending or okay. It is disabled if we are sending or we are not connected, because I mean if we are sending data already, we don't want to, you know, cause some conflict, or if we are not connected, this panel has to be disabled. So let's take a closer look at this control panel component. Yeah, all right. So what does it take? On command, kind command, and this disabled item. All right. Let's start from the top. All right. We just define the interface here, the props that we are taking in. Then this is just a mapping, of our command to the labels and the class. Okay. So command F, this forward, we'll be using this arrow and then this class button up. So this is just for conditional styling, so that when this button is active, we can change its color or something like that. We can apply styles. And then so we have forward, left, stop, right, and back. So these ones, they correspond to this. So this is forward, backwards, right, left, and stopped. So by default, it's stopped. Okay. So these are just the state labels. Okay. And then we check our components. As you can see, it's very simple. Okay. So we have the outside div for the weapon. All right. We just map through the commands, which is this item here. We just loop this. This is more like looping through this while rendering them. Okay. Okay. So we loop through this and we create this button component. All right. So this is just how we create this shape here. Okay. But we're not interested in styling right now. What we are interested in is what happens when we click. Okay, this the communication, the WebSocket communication between the front end and the back end, and then the HTTP polling between the device and the back end. All right. So on click, when we click one of these buttons, okay, each button is going to be associated with a command. Since, okay, when we loop here, we have the command, the label, and the class. So let's say we click forward. Okay, we are going to execute the on command function that we pass as a prop here, and we pass the associated or the corresponding command. Okay, so let's look at this on command function and see how it works. Okay, so let's track it back. Okay, this is our on command. Okay, it was assigned to this handle command. So let's see where this handle command comes from. Okay, so we have this handle command function here. Well, it uses the use callback hook. All right, so when we click it, all right, set sending, we set sending to true. Okay, which means we're going to disable it. Okay, after this, it's going to be disabled. Remember, we said it's going to be disabled if um if sending is true. Okay. Okay. So now we send a command. What are we sending? This command. Okay. So what happens when we like execute this send command? So let's go to um, our custom hook, right? This is where the gymnastics will be done. All right. If we go to hooks and see this use WebSockets. Okay. We want to, all right. Please don't freak out. This is just basic handling of state in our use WebSocket custom hook. So we are interested in, let's just say this part, send command, this send command. Okay. Right. If we take a closer look at our send command here, what does it do? Okay. It it uses this, if you are familiar with use ref, it does use ref to current and then opens the okay, it checks if the WebSocket is open or not. Because if it's not open, we won't be able to send anything. So if the state is open, we use this socket to send the code. We stringify this object. Okay. What we are doing is we are sending a command we're sending a message of type command, and the payload is this CMD, which is our command. It's a letter, either F or A, or I mean F or B or L or R or S. So where are we sending this? Remember, we said there is a WebSocket communication. So this is where this part, okay, this is supposed to be bidirectional. So when we click here, we are sending a control command to this backend via WebSocket communication. Okay. So let's see where this is done. If we go to our server, we're saying we are sending to the API, our backend. So let's go to our backend and see where it receives this and then sends to it receives this and then sends it forwards it as a post request to this endpoint. Okay. Let's go back to our backend. We open the server. All right. Let's go to where we define our WebSocket. So here, WebSocket on connection. And then look at this. WebSocket on message. We receive a new message. So first we check if this, okay, we actually pass it first because it's a JSON object. Okay, let me push this a little bit. Mm, all right. Mm, all right. If you check this part, we are stringifying it. Okay, we are sending it as a stringified JSON. So which means when we receive it, we need to pass it. Okay, we pass it first, and then we check, is this message of type command. Remember, when we send it, we set the type to command. Okay. So if the type is command and we have the CMD, which is this CMD, what do? We post it to the ESP32, which is what we are doing here. We are posting it to the ESP32. So the ESP32 is just waiting. It has already defined. If I receive S, I'm going to stop. If I receive R, I'm going to go right. If I receive L, I'm going to go left. If I receive F, I'm going forward. B, I'm going back. So this is the workflow. We click here, we send the command via WebSocket. So there's WebSocket communication here, and then there's a get. There's a post request here from this backend to the ESP32. So now you can see how these components interact, how they communicate. Though they are separate, you can see that okay, the device is there. It's not even connected to the computer. Backend is running on this terminal. The front end is running on this terminal. They are separate, but they have common ways of communicating. Okay. These two, they communicate via WebSocket, and then these two, they communicate via HTTP. So this is what happens when we click the button. We send the command via WebSocket communication in real time, and then we check, okay, is this a command message? Do we have the command? Then we send a request to the microcontroller. Once the microcontroller receives it, then it moves the wheels. This is what we discussed yesterday. So, let's know about that one. We're just building on top of what we learned yesterday. So just looking at this, I think you should have some idea. Like, okay, if I can have like a platform that can communicate with the Android device, what can I do? You can control multiple cars. Okay, from here you can have like an advanced dashboard where you can switch like okay, I have let's say 5 cars. I have a drop down. I want to stream car one, I want to stream car two, or you can save this data in a database and maybe display this data on a chart or something. This we are leaving you room to explore so that you come up with your own use cases. But this this demo that you have here, it covers the communication among these modules that we have. So we have the dashboard, have the back end, then we have our device here. So you can enhance it. If you want to store data in the database, you can do that here on the back end, and yeah, there is a lot of things that you can do here. So this is left up to all right. So basically, this is most of the communication that happens here. But I'm not going to explain every single line of code, but I'm going to assume that you must get the idea at this point. Okay. So yeah,
Alright, so our stream for today is going to end here. Okay, so I wish you good luck. So, we have the repo. You can clone the repo, you go through the code. If you don't understand something, you can ask in the group who can help each other. Because we're all here to learn. Okay, we're all here to learn. If you don't understand something, just try to you know, do some research. If you don't understand something, ask, and then I hope you. I would say this is the end of this part of the training. We do have another advanced um, module, but that one we may just have to record a video. We upload it to the YouTube channel. Then you can go through it. If you want to include that one as part of your project, you can, but it's a little bit advanced because it uses computer vision. But we will update you. Uh, Good night, I would say. I mean, it's evening here, so you have a good day. Okay, so our stream ends here. All right.